Hi again, Algebra 1 students. I'm Mr. Steckler from AHSP STEM. Today we are doing video number 7, which is about lesson 1-7, functions. Some vocabulary words that we'll be learning about today is function. The name of the section or the lesson is called function. A discrete function. A continuous function. The vertical line test. Function notation. Nonlinear function. Let's go to a definition of a function. So a function is a relation. So if you remember from the previous section 1-6, that was about relations. The definition of a relation was a set of ordered pairs. So a function is a relation. So we know we have a set of ordered pairs, but there's something special about this relation. And what it says is that each element of the domain, every member of the domain must be paired with exactly one element or one member of the range. So to be a function, each and every domain member can pair with exactly one member of the range. So let's take a look at some examples. For this first example, the domain and range are represented using a mapping. So as we look at the domain, there's 4 members of the domain, -3, 0, 2, 4. There's also 4 members of the range, 5, 3, 2, -1. So both the domain and range are what's called discrete. In other words, we have a countable number of each. There's 4 members of the domain and there's 4 members of the range. They're both discrete. And this relation is a function because each member of the domain, -3, 0, 2, 4, they're paired with exactly one member of the range. In other words, they get mapped to only one. Only one arrow is pointing from each member of the domain to the range. So this is a very good function. The second example is a graph. And this graph is also a function, but this is an example of a continuous function because there is not a countable number of domain and range members. There's an infinite number. This graph is completely connected. It's touching everywhere. And when it's completely connected or touching everywhere, that's called continuous. And it's a function because of something called the vertical line test, which we're going to learn about real quick. So let's take a look and see if this mapping is a function. It looks like there's 4 members of the domain. There's 4 members of the range, so this is discrete. And each member of the domain is only paired with one member of the range. There's only one arrow from every domain member to a range member. So this is a function. And the correct answer for why it's a function looks like it's letter A. Each member of the domain, each element of the domain only has one element or one member of the range. Let's take a look at letter B. This is a table. So it looks like the members of the domain, if you remember from the previous lesson, the domain are the x's. So in this case, there are 3 x members. Those 3 x members are 3, 1, and 2. There's a problem though, because the 3 is paired with 2 different members of the range. That's illegal. That can't happen. 3 got paired with 2, and 3 got paired with -1. So this is not a function. No, it isn't. Now the reason is because 3 got paired with both 2 and -1. Now sometimes we think, well, if you repeat a domain member, does that automatically make it not a function? Not necessarily. If we would have had 3 paired with 2 and 3 paired with 2, that's perfectly fine. The issue is that 3 has to pair with the same member of the range. And if it pairs with a different member, that eliminates it from being a function. Let's take a look at a word problem. At a car dealership, a salesman worked for 3 days. On the first day, he sold 5 cars. On the second day, he sold 3 cars. And on the third day, he sold 8 cars. Make a table showing the number of cars sold for each day. So in our table, there's 2 variables. One of them is the day, which will be our independent variable. The other one will be the number of cars sold. That's our dependent variable. And we were told that on the first day, so day 1, he sold 5 cars. So letter A pairs 1 with 8. That's incorrect. Letter B doesn't even have day 1, so that's out. And letter C has day 1 with 2 cars. That's incorrect. So the only answer choice that it could be is day 1 has 5 cars sold. Now let's take a look at the other pieces of information. It says on the second day, so day 2, he sold 3 cars. So 2 has to pair with 3. That's correct. And on the third day, so day 3, he sold 8 cars. So 3 has to pair with 8. So it looks like the correct table representation here would be letter D. Determine whether the equation 3x plus 2y equals 12 is a function. This equation is called a linear equation because the graph is a line. And so we're going to look at something called the vertical line test. And this is what you can use to determine if a relation that's presented as a graph is a function or not. It's really a question that you ask yourself. You say, okay, if a vertical line is put anywhere, will the vertical line touch the graph more than once? That's the question you ask yourself to determine if a graph, a relation is a function or not. So now, if the vertical line touches more than once, then the relation or graph is not a function. But if it touches only once for every single vertical line, then the relation or graph is a function. And for this graph that's presented to us, if we put a vertical line, a line straight up and down anywhere, we'll always only hit the blue graph one time. So this relation, this graph is a function, yes, because it does pass the vertical line test. Let's summarize on how functions can be represented. Sometimes functions are represented as a table where the x's are in one column, the y's are in the other column, and we notice that the y is paired with the x. This is a function because every member of the domain, every x, is only paired with one member of the range. We can also see graphs as mappings. Again, the domain members here, the x's, the -2, the 0, the 2, they only have one arrow going from them. Now notice that on the range, the number 1 has 2 arrows that shoot to it. It doesn't matter. To be a function, each member of the domain, each x, has to pair with one member of the y. Sometimes we'll see functions written as an equation like this. Sometimes you'll see y equals 1/2 x squared minus 1. Sometimes you'll see function notation, f of x equals 1/2 x squared minus 1. And sometimes you'll see functions presented as graphs. Again, to be a function, the graph will have to pass the vertical line test. Here they're presenting a function as an equation. F of x is equal to 2x plus 5. And so the question is asking, what's the function value for 3? What's f of 3? And so f of 3 means that we're going to be inputting 3 for x. 3 is a member of the domain, so we're going to input. So wherever we see x, x is going to be replaced with a 3. When you do replacements or substitutions, as we've seen in an earlier lesson, we should put parentheses. Now we'll work that out. 2 times 3 is 6, plus 5. Now we'll add 6 plus 5 is 11. So what this means is that the function value is 11 when x is 3. When you input a 3, the output is 11. 11 is the function value. F of 3 is equal to 11. Letter B is very similar, but this time the function value is for f of -8. So it's really the same process as before. If you input a -8 for x, the output turns out to be -11. Here's a word problem. This time they give us a function equation of h of t equals 180 minus 16t squared. This is an example of a function that is not linear. It's a non-linear function. So we'll start off and we'll do it very similar to how we did the previous couple problems. We will be inputting a 2 for t. T is the independent variable here, and h is the dependent variable. So now we follow the order of operations. So 2 squared is 4. Next, we will multiply. 16 times 4 is 64. And at the end, we will subtract. 180 subtract 64 is 116. In this application, 116 represents feet. So in this example, didn't say it, but 2 was actually seconds. So at 2 seconds, the height of the ball is 116 feet. H of 2 is equal to 116 feet. This time, we're being asked to find the function value for h of 3z. Very similar to the previous problem. So this time in the t location, we're going to replace t with 3z. Again, we have to be careful to follow the order of operations. We'll do the exponent first. So 3z to the second power means 3z times 3z, and 3z times 3z is 9z squared. Next, we'll multiply 9z squared times 16. That's 144z squared. Now it's time to subtract. To subtract, we look for like terms. We don't have any like terms, so we're done. So h of 3z is equal to 180 minus 144z squared. The unit on this is feet because it's a height. So when the time is 3z seconds, the height is 180 minus 144z squared feet. And that answer is letter D. And that completes section 1.7. So thank you for your attention, and we will see you next time for section 1-8. Bye-bye.